Hello, Honor Chem students. I just want to give you a brief clarification on this page. I'm hoping that you're reading through this page and that you are indeed watching this video with this chemistry teachers, the two chemistry teachers who are discussing what is Bronsted-Lowry acids. The definition of a Bronsted-Lowry acid is different than what you learned in the previous lesson about Arrhenius acids and bases. Arrhenius is that there would just be an H plus in the acid or an OH minus in the base. For Bronsted-Lowry acids and bases, they are defined as either a proton donor or a proton acceptor. In this case, a base is the proton acceptor. I want to talk a little bit about what a proton is. A proton really is just an H plus. If you take hydrogen atom. Hydrogen has one proton in its nucleus, no neutrons, and it has one electron. If you take away that one electron, you're just left with a proton. So we represent a proton as an H plus, okay? Sometimes when we're talking about acids and bases, this proton is attached to water. In reality, this always happens. The proton is always going to be attached to the water. It's very rare that you would just see a proton hanging out by itself because it's so reactive. It's going to react with almost anything, and it would be typically water. So what you should understand is this is sometimes called the hydronium ion, and it is similar to, analogous to, the same thing as a proton. It's just that sometimes we show it with water as H3O plus, as I state here, and sometimes we don't. So you should just get used to those being the exact same thing. Okay? The other piece, then, the bigger part of what you need to understand about this lesson is that when you're given an acid, and this is a generic equation for an acid where this is a generic anion, that's why we give it the A, you know it's an acid because there's an H here. But what you also really have to do is you have to analyze the reaction. Notice the HA becomes an A minus, and we literally put a tie line there. This is called then the Bronsted-Lowry acid because by definition, a Bronsted-Lowry acid is a proton donor. And you can see from this equation that the HA gave up a proton, and notice it's A minus. It's not just A, it's A minus because it gave away a proton. Well, where did that proton go? Well, take a look at the water here, and the water gained a proton. So this is a Bronsted-Lowry base, as I'm showing you right here. And this is what the Bronsted-Lowry base becomes. Those two definitions, a conjugate base and a conjugate acid, are things that you need to know. A Bronsted-Lowry acid becomes a conjugate base, and you put them together with a tie line, whereas a Bronsted-Lowry base will become a conjugate acid, okay? And you put them together with a tie line. So, it is important to note that Bronsted-Lowry acid-base reactions, only one proton is transferred from one reactant, the acid, to another, the base. If there's more than one hydrogen in the acid compound, only one proton moves at a time. Okay, so if we had something like H2A here going with water, this would become HA minus plus H3O plus. Okay, so it donates one proton at a time. Your homework tonight, or actually work to do, to practice, is please make sure you're doing this Bronsted-Lowry worksheet. This is an important understanding of Bronsted-Lowry. Make sure you know how to do that, and then complete the daily lesson quiz. You'll find the worksheets right here, and the answer is in a folder within the daily lesson page. Okay? I hope this helps. Have a great day.